Hello seniors, today we're going to see electronic assignment 22, which is particular solution of an indefinite integral. Up to now we have seen how to find indefinite integrals. Remember, the term indefinite is used because whenever we find the integral of an expression, we always have to add a plus c, right, which represents any constant number, an indefinite constant number. That's why we call this indefinite integral. So today we're going to see how to find a particular solution whenever the problem gives us a specific boundary condition, we call it. Okay, so objectives for today's class: number one, define indefinite integration as anti-differentiation. We already know that. Number two, calculate the indefinite integral of x to the power of n. We already know that. Then apply and calculate anti-differentiation with a boundary condition to determine the constant term. That's the new thing for today. And solve kinematic problems involving displacement, velocity, and acceleration. We're also going to be seeing this today. Okay, so take a look at this example. It says, if the velocity with respect to time is given by this expression, 2t plus 1, then we know that the integral of velocity would be displacement, right? So the displacement is equal to the integral of velocity with respect to time. And if we find the integral of that expression, we're going to get as a result t squared plus t plus c. Okay, if you remember from derivatives, we said that if we have, let's say we have s of t, displacement here, then we have velocity, and then we have acceleration, right? So if we want to go from a displacement to, let me use red here. If I want to go from displacement to velocity, we need to find derivative, right? Derivative. And if I want to go from velocity to acceleration, I again need to apply derivative. We're going to a lower degree each time when we apply derivatives. Let me take this a little bit down. Here, and if I do the opposite, if I have the acceleration and I want to have velocity, I will have to find here the integral of the expression. And to go from velocity to displacement, we're also doing integral. So this is something that you need to remember whenever we work with kinematic problems such as this one. Okay, that's why when we integrate velocity, we get as a result the displacement formula. Okay, so t squared plus t plus c is called the general solution for this integral over here, right? Then it says, suppose you're given that the position at time t equals 1 is 6. So here we're given something that is called a boundary condition, right? It's like an extra information that will allow us to find the indefinite or the constant value c. So if we have that boundary condition, we already know that s of t is t squared plus t plus c. So if we apply the boundary condition, we're going to say that when time is 1, our position is equal to 6, right? So we're going to set this equation to 6, and this would be equal to 1 squared plus 1 plus c. That means that 6 is equal to 2 plus c. And then we can find a particular solution of c, right? So then it says, therefore, the displacement formula is equal to t squared plus t plus 4 is a particular solution of this integral over here. Okay, we're going to see this with some examples right now. It says, if f prime of x is equal to 3x squared plus 2x and f of 2 is equal to negative 3, find f of x. Okay, so let's read this first before actually solving the problem. It says, sometimes a boundary condition is given as an initial condition. This represents a condition when t is 0. For example, if you are told that the initial displacement is 4, this means that the displacement is 4 when t is equal to 0. Okay, so that's something that you should already know. Okay, so let's see the first example. I'm going to do it here. Part A. We're given the information that f prime of x, the derivative, I'll write this better, the derivative of the function x is, of the function f is 3x squared plus 2x. And we're given the information that f of 2 is equal to negative 3. And we want to find f of x. If we want to find f of x and I have f prime of x, I will have to apply integral, right? Because f of x would be the integral of f prime of x, with respect to x, right? So that's exactly what I will have to do. I will need to integrate this expression over here. So I will have to find the integral of 3x squared plus 2x, all of this with respect to x. So we already know how to find the integral of this expression. So we're going to say that f of x, let me do this down here, f of x is equal to, if we find the integral of this expression, it's 3x cubed over 3 plus, and the integral of 2x, that's 2x squared over 2. And then we have the famous plus c, right? We always need to write the plus c. So this is the first general expression we get for f of x. Now, if I'm given this particular solution, or this extra information, which is telling me that when x is equal to 2, then the function f is equal to -3, I can apply that information in order to find the value of c, right? So we're going to say that instead of f of x, we're going to write -3, which is the solution. And this occurs when x is equal to +2, right? So we replace this with a 2. Sorry, one thing I see is that I can, for example, simplify terms here before actually doing this, and this. Okay, so let me write this better before actually doing that. This would be equal to x cubed, sorry. This is equal to x cubed plus x squared plus c. Okay, so now we replace with the particular solution. We're going to say that -3 is equal to 2 cubed plus 2 squared plus c. So if we solve this, we're going to get the value of c, right? If we solve for this, we will get that c is equal to, this is 8 plus 4, 12. 8 plus 4, -15, right? -15 is the value of c. So now we have the function f of x for this particular situation, which would be x cubed plus x squared minus 15. And this would be the original function for this particular problem. Okay? So that's how we find a particular solution. It's just applying the extra information that we're given and applying indefinite integral, which is something that you already know. Okay, so let's see exercise B. Let me separate this using a line. There. Okay, so for exercise B, we have the following. It says, the curve y equals f of x passes through the point 32 and 30. The gradient of the curve is given by, and we're given f prime of x, which is equal to 1 over the 5th root of x cubed. The 5th root of x cubed. Find the equation of the curve, okay? So we're given the gradient function, f prime, and we want to find the equation of the curve, which is f of x. So once again, we would have to find the integral of this expression before actually finding the particular solution, right? So we're going to say, once again, that f of x is the integral, let me write this down, is the integral of f prime of x with respect to x. So this is the same as saying the integral of, instead of writing it as 1 over the 5th root of x cubed, I'm going to write it as x to the power of 3 over 5 dx. Negative 3 over 5, because we're taking it up, right? So if we find the integral of this expression, this would be equal to x to the power of negative 3 over 5 plus 1, that's 2/5, positive 2/5. So x to the power of 2 over 5, this is being divided by the same thing, 2 over 5. And then the famous plus c. Don't forget about plus c. Then we're going to apply the particular solution, okay? So this is 2 over 5 and plus c. Okay, so we already have the general solution, which is this expression over here. And now I will apply the particular solution. We're given this information that the curve passes through the point 3230. So the point 32, 30 is a point of f of x, right? That means that I can replace the y value with 30, and when I do that, the x value would be equal to 32, right? So I'm going to replace that information, and we're going to have the following. 30 is equal to, instead of x, it's 32 to the power of 2 over 5 divided by 2 over 5 plus c, right? So here you see that we have only one variable, which is c. So we're going to be able to find the particular solution for this. If I rewrite this, this is the same as saying, I can take this, actually I could do that right here. 5 times x to the power of 2 over 5 divided by 2 plus c. This would be better. So I'll take the 5 right up here. 5 times that, or 2 plus c. So then I can take, for example, if I do the fifth root of 32 squared, that is equal to 4. Okay, you can do that in the calculator if you want. You would get that this is equal to 5 times 4 divided by 2 plus c. Then I can simplify 2 with 4. This would be 2, 1. So we're going to have that 30 is equal to 5 times 2, that's 10 plus c. So the value of c for the particular solution is equal to 20. Okay? And that means that the function f of x is equal to this expression here, right? 5 times x to the power of 2 over 5. This is being divided by 2. Plus, instead of c, we're going to write the particular solution, which is 20. Okay? So this would be the result for exercise B. Now let's see exercise C. Let me separate this first. For exercise C, we have the following. It says, the rate of growth of a population of fish is given by, and this is the derivative of p with respect to t, and that's 150 times square root of t. And it says, for this interval, from 0 to 5 years, the initial population was 200 fish. Okay, so this is our boundary condition. Then it says, find the number of fish at t equals 4. Okay, so let me write the information first. The first thing we have is that the derivative of p with respect to time is equal to 150 root t. And then we have that the initial population was 200 fish. So if the initial population is 200 fish, it means that at t equals 0, the initial time, population is 200. That's the boundary condition for this problem. So if I want to find the number of fish, right? Find the number of fish at t equals 4, right? I'm given the rate of growth of the population, which is this expression over here. But if I want to find the equation for the population, then I will have to integrate this expression with respect to time, right? So that's what I need to do. To find the population formula or the population function, we are going to have, this is population with respect to time, we're going to have to integrate the rate of growth, which is dp over dt, with respect to t, right? With respect to dt. So this is the same as saying the integral of 150 times, instead of root t, I can write this as t to the power of 1/2. And this is dt with respect to t. Okay, so I find the integral for this, and we're going to get that this is 150 times t to the power of 1/2 plus 1, that's 3/2. 3/2, right? So this is times, sorry, to the power of 3 over 2, and this is being divided by 3 over 2 plus c. So if we reorganize this would be 150 times 2, that's 300. And 300 divided by 3, that's 100. So I can leave this as 100 times t to the power of 3 over 2 plus c. So this would be the general expression for the population formula, right? Okay, so now I will apply the boundary condition. At t equals 0, my population is 200. So instead of writing a population with respect to time, we already know that this is 200. 200. Let me write what I'm going to do first. What I'm going to do is say that at the population at time equals 0 is equal to 200. So I'm going to replace p with 200, and using this expression here, I'm going to replace time with 0. So this is 100 times 0 to the power of 3 over 2 plus c. Okay? Any number to the 0 to the power of any exponent is always equal to 0. So here we're going to have the particular solution, which is 200, right? So the value of c is 200. That means that the population expression, population formula, is the following. 100 times t to the power of 3 over 2 plus 200. This is our population equation. But that's not the end of the problem. So once we have the expression, we need to, the problem is still not done, right? Because we still need to answer the question, right? Find the number of fish at t equals 4 years. So now that we have the expression for the population, to find how many we have after 4 years, I will have to replace time with 4, right? So I'm going to find p of 4, basically. So p of 4 is equal to 100 times t to the power of 3 over 2. Sorry, not 3 over 2. Times 4 to the power of 3 over 2 plus 200. Right? So how do we find this? 4 to the power of 3 over 2. We can think about doing the following. 4 to the power of 3, that's 64, and 4 to the power of 2, that's 14. So 64 divided by 14, 64 divided by 16, that is equal to 8, right? Yes. So we're going to say that P4 is equal to 100 times 8 plus 200. So finally, the population after 4 years would be equal to, this is 800 plus 200, that's 1,000. So 1,000, we're talking about fish, would be the population after 4 years. And this is the answer for this problem, okay? So I hope this is being clear for you people. Let's see this last example, and then we're done. It says, the velocity v in meters per second of a moving object at time t seconds is given by this expression. Vt equals 3t squared minus 2t. When t equals 3, the displacement fs of the object is 12 meters. So this is our boundary condition. Find an expression of s in terms of t. Okay. To solve this problem, you should already know that the displacement function, which is what we're being asked in the problem, is the integral of the velocity function, right? So we're going to start by doing that. We know that displacement is the integral of velocity with respect to time, right? So that's exactly what we need to do. We need to find the integral of the velocity expression, which is 3t squared minus 2t dt. So we find this integral, and this would be equal to 3t cubed over 3 minus 2t squared over 2 plus c. I see that we can, for example, simplify terms. This one, this one, this one. So we're going to get as a result t cubed minus t squared plus c. This would be the general expression for the displacement formula. But Now, I have, let me write this down, s of t is t cubed minus t squared plus c. We have the particular solution. When t equals 3, the displacement of the object is 12 meters. So 12, when the displacement is 12, our time is 3. So 3 cubed minus 3 squared plus c. So then I just need to solve for the value c, right? We're going to have that c, this is 12. This is 27 minus 9, 27 minus 9, that's 18, plus c. So we're going to get that c is equal to negative 6. That means that the expression of displacement with respect to time is t cubed minus t squared plus c, where c is negative 6. So this would be the answer for this problem, okay? This is the particular solution according to this boundary condition that we're given. Okay, so I hope this was clear, seniors. I think it's quite easy just applying the same integral concept, but then having a boundary condition in order to find a particular solution, okay? So I hope this was clear. If not, please let me know. We're going to clear it up in future live sessions. Thank you for your attention and see you.